In this lesson, we'll look at ways to remove large amounts of material with adaptive toolpaths. After completing this lesson, you'll be able to create a 3D adaptive clearing toolpath. Let's carry on with the file from our previous example and get started by expanding the bodies folder and showing the 5045BN prop. We want to select Setups, go to our Setup dropdown and create a new setup. We're going to be using milling, and we want to make sure that we only select the prop. We want to turn on fixture, and we want to select the green body as our fixture. You also notice that there is an option for fixture attachment if you have any clamps or hardware. We want to make sure that we use the model orientation and set the Z-axis as our current Y-axis, and we're going to leave it at 0 at the center point of this part. This is going to be the way that we set up our X and Y coordinate system. Under post-processing, we're going to change it to 1003, and we're going to say prop part 1 for our program comment. The stock is going to have some additional stock setup, and we're going to actually add 2 millimeters to the sides, and we're going to add 1 millimeter to the top, and that's going to be okay. We're going to say okay. Now, in reality, the way that this part would be held on here is it would be pre-drilled and pre-faced to the right height. Once it's pre-faced and pre-drilled, we would have a bolt here, and that way we could go around. Now, in our case, we're only focusing on certain operations, and we're not actually taking a look at cutting this part in reality. But again, what we would do as a first operation would be to pre-drill and face it and actually machine the slot on the other side. So that way when we set it down, it would key in place and keep it from rotating. So with this setup created, we now have setup 2, and notice that it is active. The same way that you activate a component to work on it in the model workspace, you need to have a setup active if you want a toolpath to be used inside of that setup. I'm going to minimize setup 1, and we're going to start working on setup 2. I'm going to start with 3D, and I'm going to use 3D adaptive clearing. The tool that I want to use is the 10 millimeter tool, and the boundary, notice that the boundary is currently set up to be the size of our stock. Now that's okay because it is going to allow us to go outside with the tool. We're not really fixed in that location. We're going to go into our heights, and again we're going to leave all the default, and notice that the bottom height is at the bottom of the part, but it's above the fixture. Now this is important because this allows us to make sure that our tool doesn't go down too far. So we're going to keep that bottom height exactly where it is. For our passes, we can allow it to machine shallow areas. Now in our case, we don't really have that. We're only going to be focusing on the props from the top. We can also tell it to machine cavities. We can use specific slot clearance algorithms, but in this case, again, we don't have a slot, so we're not going to turn that on. We can have a maximum roughing step down, and we don't want to go down too much because the size of the prop is actually only about 7.5 millimeters. So we're going to say that the max roughing step down is actually 1, and a fine step down is going to be 0.1. We can use flat area detection, but the only flat area is the top of this face, so I'm not too worried about that. We can order by depth or area. We're going to leave stock, but we're going to leave a smaller amount in the radial and axial directions. We're going to go to our linking parameters, and we're going to leave all of the default settings here. And I do want to notice that we do have a vertical lead in and lead out. We have a horizontal lead in and lead out. So this is different than what we've seen so far from our 2D operations. Helical ramp of 2 degrees by default, and we're going to say OK. Once the toolpath calculates, take note of all the different passes and how the passes are being done at different heights. Because of our max step down and the way that it's approaching the curvature, you can see that we're doing a bunch of horizontal passes to get rid of that geometry. Before we go any farther, I'm going to do a quick simulation of that operation, and I'm going to turn off transparency. I want to see the stock, but I am going to turn off the tool, and I want to play through this and take a look at what's being cut. So as we go through, you can see it's making each step as it goes down. We're going to change the material so we can see it a bit better to ceramic. And you can see how it's cutting the top of the blades. Now we could do this again with finer step downs if we want to, but really the way that we want to use this operation is to rough a lot of material. We left 1/4 millimeter on top. And this gives us enough material to go back with a smoothing pass with a ball end mill or a bullnose mill, and then we can go back on a finishing pass as well. So for right now, we're going to close, and we want to save the file before we make any more toolpaths.